When you need to fasten two pieces of metal together, one of the common ways of doing that is with welding. And the basic idea is you melt the two pieces of metal so they become liquid. Then when they harden, that liquid hardens into one solid piece. That's the basic idea. And then in the joint where you're welding them together, there's also some filler material that comes from a rod or a piece of wire. There are a whole bunch of different types of weld, but we'll just look at the common ones. Arc welding, as the name implies, comes from an electrical arc. You know, if you've ever seen a wall outlet short out, or somebody stick a piece of metal in a wall outlet and not die, or seen a lamp cord short out and you've seen that bright arc, well, that arc creates a lot of heat and it can melt metal. So with stick welding, this is the common portable kind of welder. It looks kind of like this. Usually it's red if it comes from Lincoln. And home welders will sometimes buy these. So you put the stick in the clamp. The stick melts as you weld the piece and you use it up, and then you go get another stick and keep going. In a manufacturing setting on a shop floor, you will see wire welding oftentimes. And wire welding is you don't have to stop and replace the stick. It's got a spool of welding wire that just feeds through the gun. Gas welding, where you see these tanks of oxygen and acetylene, this can be used for hard facing. That's the kind of welding I did for a couple years. It can be used to cut, although cutting is not exactly welding, it's more burning the metal, but we still use oxyacetylene for that. But another kind of welding that has gas in its name is gas metal arc welding. And here there's a gun that feeds an inert gas. Inert means it doesn't react. It doesn't oxidize, so argon, helium, or something. Gas metal arc welding uses wire that comes through the gun. Gas tungsten arc welding uses a stick, and you may have heard this in the olden days referred to as TIG welding or heli-arc welding. This is the kind of welding that people use when they're doing like stainless steel restaurant hoods, non-ferrous metals, stainless steel, any other kind of metal. Now I know stainless steel does have some iron in it, but it's not like welding regular mild steel. You can weld other kinds of metals that really are non-ferrous and metals that are really thin. This is a more high skill level of welding than wire and stick welding. It takes a lot of practice, and it makes beautiful welds. Then in processes where you see, steel cans used for canned food or auto body parts or that kind of thing, they will use resistance to heat up and melt the metal. Think of an electric stove burner. It's resistance that causes the stove burner to get hot. Likewise, with this weld, it's resistance that causes the weld material to get hot. And then there are probes that fingers that press together on either side of the weld and push the melted stuff together. So in the method called spot welding that uses resistance and pressure, you wind up with these little dips in the metal. And if you've seen some hidden parts of car bodies, like under the hood where you see those little dips in the metal, that's the result of spot welding. Here's some spot welding happening at a shop in Eugene. This was an SME tour. When you're deciding what kind of weld to call out on your drawing, that is based on what kind of joint you've got. What shape do these pieces of metal form when they come together? And there are only a limited few number of joint shapes. The metal could be butted together, overlapped, could come together in a T or in a corner, or you could have two edges, and that's about it. Everything else is just a variation of one of these 5 joints. And so when you're calling out the type of joint, you're really calling out what shape is the place where the two pieces of metal come together. And we're going to learn the symbols for each one of those. Each one has its own symbol, and the symbol is a picture of the shape of the weld. This one, the triangle, is a fillet weld, and you can see that's kind of a triangle shape. Here in the upper left corner is a picture of a fillet weld, and you can see that there are two kinds of joints pictured here that will allow a fillet weld because they make a corner. This T connection, you can do a fillet in there. An overlap, you can do a fillet in there. And the other one I wanted to mention was the outside corner. You can do a fillet weld there. Then groove welds are the kinds that you do when you butt two pieces of metal together end to end. And there are various shapes of grooves, and each one has its own symbol. And then flange welds, we won't really talk about those. Those are less common in a lot of the work we do around here. Plug welds are holes in one piece of metal through which you weld to another piece of metal. It's basically a fillet weld around the inside of a hole, and this is a way to attach like a liner inside of a hopper, that sort of thing. Weld standards come from AWS, American Welding Society, and they write standards for all kinds of subjects that have to do with welding. They write standards for how to determine the quality of a weld, you know, things like porosity and all that sort of stuff. They write standards for certifying welders. So if you're going to be a welder, you have to take a certification test. There's a whole range of tests that you can take from beginning to advanced. That's not what they call them. And so AWS writes the standards for what the test shall be. What we are concerned with is AWS's standards for drawing symbols, and we'll learn what AWS says about fillet welds and different kinds of groove welds. So we'll go on and do that next, beginning with fillet welds.